Hi everyone, this is Dr. Mahmoud Al-Odeh for 3267 Economics and Cost Analysis. We're going to cover in this video uh, conducting present worth analysis for two alternatives. So in the previous video, we did discuss if we have a one alternative and how we could build the cash flow, or we could use the interest rate tables, or we could use the equation. For this video, I will be talking about conducting in present worth analysis for more than one alternative with equal life, and also we're going to talk about more than one alternative with unequal lifetime. So for example, if we have a one alternative, what we need to do, or more than one alternative with equal useful life, we need to find the net present value for all the alternatives, and then we select the alternative with the higher net present value. So let's go ahead and demonstrate this concept using example 3. Example 3, a construction company is planning to buy one of the following equipment for a construction project in Minnesota. The information for the alternatives are provided in the table below. Find the best option, machine A or machine B, to be selected. So as you see, we look into the initial cost, the benefits, the lifetime, the salvage value for both, and interest rate. The first thing I want to do is to look at the lifetime for these alternatives. As you see, this is equal life for alternatives. So machine A will last for 20 years, machine B will last for 20 years. So what we need to do, we need to build a cash flow. So I'm going to switch to Excel here and show you how we could finish this example. All right, so what I'm going to do as well, I'm going to copy the question, bring it to Excel as well, so you can see it while we're doing the answer. All right, here you go. So again, so what we need to do, we start with the lifetime. These alternatives has an equal lifetime. So we build the cash flow from 0 to 20. And the cash flow table will consist of two columns. One column is for the years and another column for the cash flow. And because we have two alternatives, we add another column for alternative B. So starting with year 0, we have a negative $80,000. That's the initial cost. And then moving into the year 1, we look into what transaction happened on year 1. There is only one transaction for this alternative machine A, and that's a benefit per year of $12,000. So that would be $12,000. And then same thing for all the years from 1 to 19. However, on year 20, we have the $30 salvage value. So $30,000 should be included on year 20. It's a positive, it's a salvage value, something coming into your pocket. So we should consider it as a positive. So that would be 42,000 as a net cash flow for that year. And now we are ready to apply the net present value. We applied the NPV function 10%, selected the cells from 1 to 20, and then added the year 0 to it to find out the net present value for machine A, for alternative A, would be 26,000 positive. Be careful, it's a positive 26,000, which means that option, that alternative is making money for the company. Now we're going to do the same thing for alternative B, starting with the initial cost of negative 66,000. Look into the transaction over the years from 1 to 20. You will see that there's only one transaction, which is the benefit per year. If there's a cost per year, we should consider it as well. But for this example, we don't have the cost per year. And it looks like this cost per year is included with the initial cost, or maybe they have a plan that they will take care of maintaining the machine over the years. So it's really up to how much details we have. So we don't have any cost here. Therefore, we only have one transaction, and this transaction is 9,000 positive, 9,000 benefit from year 1 all the way to year 19. On year 20, we have also, should we consider the 9,000 and the 40,000 as salvage value. So now we have ready, the table is ready to be conduct the net present value, the NPV. The NPV is 10%, and we select all these cells, add to that the initial cost to that. And now, as you see, this is also going to provide a positive net present value, which means this also can make money. However, if we need to select only one, we go with the highest net present value. And in this case, machine A will be more profitable to be used and to be selected. Therefore, the company should select machine A or alternative A. Now, we're going to see if we have alternatives with different useful life, such as here, let's go over the background information first. When we have more than one alternative with unequal useful life, we use a technique called the least common multiplier. And the least common multiplier, it's a technique that we use it to find out for how long we need to conduct this analysis. So for example, if we have alternative with 2 years of useful lifetime, and 3 years for another alternative, the least common multiplier would be 6 years. And so therefore we need to conduct the analysis for 6 years. What does that mean? We have to buy 3 of the first alternative because it has 2 years useful life, and 2 of the second alternative, and then we find the present worth. All right, let's go ahead and jump to an example to demonstrate this concept. We have example 5 here. A local manufacturing company is considering buying a packaging machine. They found the following 3 alternatives. If the interest rate is 10%, find the best alternative using the present worth analysis. So let's take a look into Excel. So I'm going to switch to Excel here. Okay, so we have the initial cost, we have the benefit, we have the cost per year, we have the salvage value, we have the life as well. So we have 50,000, 27,000, 18,000. Benefit per year is 11,000, 8,000, 6,500. Cost per year is 4,500, 3,500, and 3,000. Salvage value 20,000, 12,000, $7,000. The lifetime for these machines, machine A would be 6 years, machine 2, 3 years, machine 3, 2 years. As you see, these are unequal lifetimes, so we need to make this lifetime equal to each other so we could compare them. So the least common multiplier between 6, 3, and 2 would be 6 years. So let's go ahead and build the cash flow for each one of these machines, and we will conduct the analysis, the net present value analysis to each one of these machines. So machine 1, we have $50,000. We're going to run this machine for 6 years. Look at the transaction every year. You will see 6,500, a net 6,500, and the 6,500 coming from the benefit minus the cost. As you see, the benefit is 11,000, the cost is 4,500, the net cash flow would be 6,500. The same thing from year 1 to year 5, and then we add the salvage value on year 6, the $20,000. So this is something similar to what we did in the previous example. And then once we have it, the table is ready, we could apply the NPV function, 10%, select the values from 1 to year 6, add to that the year 0 to it, which is the negative 50,000, and that would be the $10,401. Now moving to machine 2, this machine will last for 3 years. However, the analysis will be conducted for 6 years, so we have to buy 2 of these machines, one on year 0 and one on year 3, or by the end of year 3. So on year 0, we have 27,000, negative 27,000, that's the initial cost, and then 4,500 on year 1, 4,500 in year 2, and now year 3, we have to stop and think what the transaction should be on year 3. We have to collect the benefit of 8,000 minus the 3,500, the cost, plus the $12,000, that's the salvage from the old machine, and we have to subtract 27,000. That's the initial cost for buying a new machine. Year 4 and 5 would be just only the 2 transaction benefit and the cost, so you subtract the benefit from the cost to have a 45,000 as the net cash flow in these years. Year 6, we have to think and see how many transactions happen on that year. Year 6, you will see the benefit, the cost, and the salvage value. There's no need to buy any new equipment on year 6. And now the table is ready to apply the net present value. You use the NPV, 10%, and select the cells. And the last machine, machine 3, this machine will last for 2 years. So every 2 years we have to buy a new machine for over the 6 years. So we need to buy 3 machines, one on year 0, one by the end of year 2, one by the end of year 4. So year 0 would be the 18,000. 3,500 would be the net cash flow, which is the benefit minus the cost. 6,500 minus the 3,000. On year 2, we have to stop and think how many transactions would be on that year. We will have the benefit, the cost, the salvage value, and buying a new machine, and that would give you a net cash flow of 7,500, negative 7,500. Year 3, it's just only 2 transactions, the benefit minus the cost, and that will give you the 3,500. And for year 4, we have to stop and think. That's a new cycle for this machine. We have to buy the new machine, we have to collect the salvage, and also consider the benefit and the cost from previous year. So 7,500 minus 3,000 plus 7,000 minus 18,000. That's the initial costs for buying a new machine. Year 5 would be just 2 transactions, the benefit and the cost. Subtract benefit from cost. That would give you 3,500. And for year 6 would be we have to think how many transactions. We have only 3 transactions, the benefit, the cost, and the salvage. There is no need to buy a new machine for that. So what is that? Okay, now we're done. We did build the cash flow, and now it's time to develop to write the NPV function, 10% for these values, and that will give you a negative $15,409. And the last thing that we need to do is to make a conclusion on what option we should select, which machine we should select. As you see, machine 1 it looks like it has the lowest cost because it's negative. We're dealing all with negative numbers here, and the highest NPV here would be machine 1, or in a different way, you could say machine 1 will cost less money. This machine, if we buy it, it's going to cost us negative $10,000. So we have to pay out of our pocket $10,000. Machine 2 will have to buy about $12,000. Machine 3 we have to pay $15,000. So as you see, the machine 1 is the less expensive one. It is the one that has the highest NPV, and therefore machine 1 should be selected. And I know some people will get confused because I said the highest NPV and I selected the 10,000, but remember this is a negative number, and the highest number in the negatives would be the lowest number in between them. All right, well, I hope this is helpful. Now there's a video on the infinite life, unlimited lifetime for projects such as the bridges, hospitals, parks, etc. These are usually the government projects. So there will be a video on how to find the capitalized cost or the present worth analysis for these kind of projects, the unlimited life for these projects. All right, thank you very much. Please let me know if you have any questions.